Hi everyone, welcome back. Today we're going to be looking at the brain. This is a triple science specific topic, so if you're doing double science you could stick around and learn, but for you triple scientists out there, this is something that you'll have to learn for your exams. So today we're going to be covering the brain itself, what its role is, what parts make up the brain, and how scientists can study the brain to help us understand a bit more about what's going up here. Okay, first thing we need to look at is the brain itself, what its role is and the structures within. So the brain, you probably know, controls your body. It's you know what pilots the flesh suit that is a human being around. The brain, if we're looking at a definition that we can use in GCSE, is a structure that controls all the complex behaviours in your body. So we're talking thought, memory, speech, consciousness. Things like reflexes, remember, aren't controlled in the brain. The messages don't go there, it just would take too long. So the brain stem and your spinal cord is what carries out your reflexes. Now your brain is fairly large, but it's actually not very solid. When you look at pictures of brains in books, or if you look at specimens of brains pickled in jars, often they seem quite firm, but in reality your brain has got about the consistency of Angel Delight or a blancmange, one of those flans. But the reason why it is so floppy and mushy is because it's not made up of much other than water, fat and neurons. So you have billions of neurons within your brain and they're all interconnected and put into regions, so your brain can process a lot of information really fast, like the most complicated computer you can think of. It doesn't even come close to the brain. The brain is amazing. Right, now for the fun bit that I love is drawing the structures of the brain. I've actually done myself a little picture on a wall in my office. I have chalkboard paint, so I'm just going to show that on the screen now to show how much of a nerd I am. You don't have to know this many regions. We just need to look at 4 particularly. And again, I know some of you aren't the world's best artists, so we are learning science, not art. So you can just draw literally a stick and a circle, something like this, and just label the sections on. That's fine. You're never going to be expected in an exam to recreate it. You're not, Picasso, nor am I, to be honest. So I would draw yourself a rough shape. Get yourself 4 different colours if you have them. If not, just make sure you have some way of identifying the different areas, maybe sketch them in different shades, and we'll go from there. So give me a second. I'm going to draw up all the regions and then I'm going to talk through them one at a time. Right, now you've created your masterpiece, we need to go through the different sections one at a time and just talk through their functions. So the first area we're going to look at is the cerebral cortex, which is made up of your 2 hemispheres. So if you're looking at a brain straight on, it's almost like a mirror image. So you have 2 large sections, which is the bit, when you see a brain, it's the wrinkly bits, that's the cerebral cortex. They are split into 2 hemispheres, your left and your right. So when you see the term cerebral hemisphere, they're talking about, those different sides. And the cerebral cortex is the whole meat crash helmet thing. The cerebral cortex is really highly folded, so it's what gives the brain its wrinkly appearance, kind of like, your fingers if you've been in the bath for too long, or a prune, everybody's favourite elderly person treat. Though, no joke, prunes are actually pretty good. This is what controls your intelligence, personality, consciousness, thoughts, all those high level functions. So the things that make you you are in this cerebral cortex area. Now the areas are split up into different regions, as you would have seen in the picture I put up before, but for now we just need to know this big area as the cerebral cortex. Tucked away at the back of your brain is a little area here that sort of looks a bit like a flower if you were to cut it up on the inside. Still, it's quite folded to give it a large surface area. Your cerebellum is the main place that is your coordinator. It controls your balance and your movement. So, those of you that are good at dancing, unlike me, or gymnastics, when you're, getting yourself into a beautiful pose. That's what stops you from falling over. My cerebellum clearly doesn't work because I bump into stuff all the time and covered in bruises. So there we are. Okay, the medulla is a bit of a strange bit. In lots of diagrams, you'll often see this whole area coloured in one area. This big bit in orange is called the midbrain because it's sort of tucked in the middle. The medulla, the oblongata bit that we're concerned about itself, is just this little region here. So your medulla oblongata is actually the part that sort of protrudes out and is the first section of your spinal cord. So it's right at the base of your neck where you can sort of feel it dipping in. Now your medulla oblongata has a bit of a strange name, but it does less strange stuff. It's you're doing your unconscious thoughts, and it sort of controls your heart rate, your breathing. So again, that's why when people have breaks in the neck or breaks very high up in the spinal column, that's when it can cause death, because you are severing the neurons that control your heart rate and your breathing. So it would be the medulla that is concerned with the reflex arc that we've done previously in the year. Okay, last region is probably one of the most important ones, only secondary to pituitary gland, is your hypothalamus. So it's deep within the sort of middle of the brain. Your pituitary gland would actually not be that much further below it. It would be down here, like a little, I don't know, couple of peas, or, well, I can imagine what you're thinking that is. So, your pituitary gland, might as well add it on. We all know is really important in regulating blood sugar. And it also releases lots of those hormones that are used in the menstrual cycle. Right, now I'm back on track, back to the hypothalamus. Your hypothalamus is your regulation centre. It controls things like water balance and temperature in your brain. We'll be looking at temperature and water balance in a bit more detail in a future video, but just for now, when we're talking about those and negative feedback, you're thinking of your hypothalamus. And that, in a nutshell, is the brain. The brain is one of the least understood parts of our body just due to its incredibly complex nature. So before we start looking at how scientists and doctors study the brain today, we need to look back at the past, at how brains were studied in the past. But I'm going to explain through some series of unfortunate events, I'll call them. So, first person we're going to look at is a chap called Phineas Gage. Phineas Gage was a foreman, so he was like a manager working at a railroad company back in 1848. What happened one day is he was supervising some workers as they were building the railroad. Now, Phineas Gage was a well-liked member of the community. He was often quoted as being a smart businessman. He was a very polite and well-spoken person, and all around a pretty good bloke. Now, Phineas's job was, as I said before, managing a railroad. And what happened on this fateful day in 1894 is he was supervising some construction happening on a new line. Specifically, they were blasting rocks with dynamite to clear space for new parts of the track. What happened is one of his workers was trying to get his attention, and Phineas turned around to sort of see what the guy was, wanted or what he was up to. And unfortunately, at the exact moment that he turned around and opened his mouth to say hello or what's up, there was an explosion. Now, unfortunately for Phineas, what happened is during the explosion, a 1.5 metre long steel pipe was blasted by the explosion and hit Phineas directly in the head. Now the steel rod, sorry for any of you that scream shout there, the steel rod went in through his left jaw, went in his head, behind his eye socket, and actually popped out the back of his head cleanly. Now, miraculously, Phineas lived. He had the pole removed, and it turns out it didn't hit anything major. I mean, it did damage his left eye, but it didn't destroy it. He did lose some vision, but for having a massive pole through the head, he came off pretty all right. After the accident, Phineas had changed for the rest of his life, but the biggest change wasn't anything physical, it was his personality. So whereas before people described Phineas as being a nice man, a welcoming member of the community, really smart and energetic businessman who wanted to get things done, after he recovered from his surgery, he completely changed. He would go through shouting profanities in the street, he turned to heavy drinking. So this helped scientists and doctors at the time, or help us link now, that the cerebral cortex, which got damaged during the accident, is what controls personality. Whilst looking this up, this was my favourite quote: "He became intolerable to decent people." So I just let your imagination run wild with that one. The way they've linked the fact that Phineas's cerebral cortex was damaged is modern scans or modern modelling using Phineas's skull have mapped out where they think the most damage would have happened, and they did indeed find the most damage to his cerebral cortex in the same place where the rod went through. So this term here, social inhibition, is just a posher way of saying controlling how you behave when you're out and about. So if you don't have much social inhibition, you've got no filter, you'll just shout whatever comes into your head, be it something naughty or something nice. There's one more tale of woe I want to share with you that links to another region of the brain. Now, there was a chap called Henry Gustav who in the 1950s suffered from really severe epilepsy, so he'd have seizures quite often. And at the time, there wasn't much in the way of treatment for epilepsy, so if you had epilepsy, it was a completely life-shattering disease. If you had seizures, it often meant you couldn't work and couldn't earn money. Now, as treatment for his epilepsy, Henry went to some very drastic measures, and he had some surgery that actually removed both halves of his hippocampus, which is another region of the brain in the middle. Your hippocampus is part of your midbrain, and at the time they didn't know what that region of the brain did very well. After he had this part removed, what unfortunately happened was that when he had the hippocampus removed, it didn't really affect his epilepsy, I don't think, but the main problem was he had severe memory loss, so long-term memory loss. He could remember things that happened fairly recently, but he had no long-term memory, so he couldn't commit anything new to his, or remember anything long-term. However, Henry's bad experience did lead to some good, as we now link the fact that the hippocampus is where memory is stored. As the brain is inside your skull and it controls all of your complex processes, studying the brain itself is very hard to do, and it's only something we've been able to do well in fairly recent terms. There are three main ways you can study the brain. First one, as we've looked at with my series of unfortunate events, is you can look at the brains of people that have had brain damage or other disorders after their death and look at how the brain has changed. Another way of looking at the brain is to actually look at it whilst people are performing surgery. So what I'm going to do is just run a clip in a second that shows actual brain surgery happening on someone that's awake. The reason why they have to do this is to maintain the brain's functioning whilst they're working on it. So often people will be clamped in place and they'll be asked to talk, or they'll be shown something on a screen that allows them to see their brain activity and make sure that every time that they're removing things or working on the brain, they're not causing permanent damage that could affect that person's lifestyle.
So you're from
Yeah.
All right, moment of truth, Joel. We're gonna drill a hole in your skull now. The drill is very loud. It's loud to us, but to you it's gonna be super loud, okay? It will not hurt though.
Okay.
All right, here we go. Loud noise. All right, how was that?
I haven't much fun since last week and now.
Yeah, you're a member of an elite club. Very few people can say they've had a hole drilled in their skull while they're awake. We're gonna open up that covering over your brain and see if there's anything inside.
Okay, the last way that doctors study the brain, and the way that's most used today, is through MRI scanning. Now, MRI stands for magnetic resonance imaging. Now, if you've ever seen an MRI machine before, it's sort of kind of looks like a washing machine. You have the table that slides in and out, circle sort of a tube, a tunnel where you are placed, and this is very, very claustrophobic. It's not too bad. It's quite noisy. They often give you music to listen to, but what happens is the reason you get slid into the machine, and the reason why it's a tunnel, is there's a very large magnet that spins around, and that is what's used to take images of your brain. The X-ray wouldn't work, as that radiation just will penetrate the tissue, but with MRI you can see the individual regions of the brain, and even as they are working you can take pictures. The biggest drawback of anything that is to do with the brain is the fact that it's so delicate. So in exams you might be asked to evaluate, so give some good and bad points about them. So for good points you want to mention that things like MRIs show exact areas of the brain. It's very, very accurate, and you can look at people that are diseased or injured without having to do surgery on them, potentially cause them harm, or wait until they're dead and have a look at their brain then. With studying patients with disorders of the brain, you can sort of try and link regions of the brain that you've seen through MRIs with their actions, or again you can get to the brain for autopsy, but again you need permission from the family and it raises some ethical concerns. And unless we can see those regions lighting up whilst the person is going through their day-to-day lives, there's still a lot of trying to connect the dots, so to speak. With surgery, again, the brain is very delicate. One slip of a scalpel in the wrong place could end up with someone not being able to talk or having to relearn how to do even the most basic things. So often the surgery is done by very highly trained surgeons. They will ensure that surgery doesn't damage any important functions, but again, it's always a risk. So a good example is the violinist playing an instrument during surgery. You can even find that clip on YouTube if you searched hard enough. It's a mind bender. Right, that's us done for the today. I've put a task for you to do on the Google Classroom. If you could just fill it in and attach it, that'd be fab. And I will see you next time.